Okay, so here we go. Last part of the practice final exam, number 16. Kathy stood in the middle rung, up 4, down 2, up 9, 3 more to the top. All right, let's just map it out. So Kathy started here in the middle, right here, and then she went up 4. 1, 2, 3, 4 to right here. And then she went, what? Down 2. 1, 2 to right here. And then up 9. So up 9, up 1, 2, 3, 4, 5, 6, 7, 8, 9 to right there. And then what'd she do from there? 3 more. Up 1, 2, 3 to right there, which is the what? The top. So how many total rungs are above her? Let's count them. Because this is the middle right here. This one's the middle. There's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14 rungs above. Now if this is the middle means there's the same amount above and below. So if there's 14 rungs above, there must be 14 below and 1 in the middle. So there's 14, 1, 14 on that ladder, right? So that's 29 rungs on the ladder. Okay, so I'm on number 17, starting with this right here. I want me to find the 100th term and the nth term. So how do you find the 100th and nth term? Let's start with the nth term, the formula. So what's happening in this sequence? If you look at it, it's adding 6 every time, right? Plus 6 every time. That's arithmetic. So if you're in arithmetic, you're adding or subtracting the same number each time. I gave the formula. It's a sub n is a1 plus n minus 1d. So the a sub n form is a1. a1 is the first term. D is the jump, or the difference. D stands for difference from term to term. The difference term to term. So the first term is 1. And the difference from term to term, the D, the difference from term to term is 6. So simplify that formula. 1 plus distribute that 6. 6n minus 6. 1 take away 6, negative 5, plus 6n. So there's the a sub n formula. That formula, so that goes right here. You can write it the other way, 6n minus 5 if you prefer. It doesn't matter. And now, how do you find the 100th term? Well, you plug in 100. It's minus 5 plus 6 times 100. Minus 5 plus 600. 595. 595 is the 100th term. Okay, so B, same kind of thing. This one is adding what, 40 each time? So this formula, part B, a sub n is a1 plus n minus 1d. First term is 70. The difference from term to term is 40. That's the d. All right, simplify that formula, distribute here. What do we get? 70 minus 40, what's that, 30? 30 plus 40n, so there's this right here. The nth term formula. Now, I want me to find the 100th term. So the 100th term will be 30 plus 40 times 100. You plug in 100 for n. That's 30 plus 4,000. That's 4,030. That's the 100th term. Let's go on to part C. It wants the 100th term and the nth term of 1, 2, 4. So part C, 1, 2, 4. What's it doing every time here? It's going times 2. Times 2. And that's called a geometric. And when it multiplies the same number. So when you add the same number every time, that's an arithmetic sequence, and I gave you the formula for that. If you multiply the same number every time from term to term, that's a geometric sequence, and it's a different formula. Here it is. A sub n is a1 plus r to the n minus 1. R is the ratio of any term divided by the previous term. That's what R is. So, okay, so we have this formula. Let's do it. A sub n is a1. What's the first term? 1 times R. What's the R? What's the ratio? What's it multiplying by every time? That's the 2. See, if you take any number, divide by the previous, 4 divided by 2 is 2, or 2 divided by 1 is 2. Right? Any number divided by the previous term is always 2. That's the ratio. That's what you're multiplying by every time, because that's what you would divide to get, to the n minus 1. So you don't even need the 1. The 1's not doing anything. 2 to the n minus 1. Whoops. Bring it down here. 2 to the n minus 1. That's the nth term formula. Now, how do you find the 100th term? 100th term, we just put in 100 for n. 2 to the 100 minus 1, 2 to the 99. We're not going to figure that out in our calculator. It's just gigantic. We'll just leave it 2 to the 99. Okay, so part D, 100th term of that, what's happening? 9 to the 1, 9 to the 4, 9. See those numbers? They're just adding, the powers are just adding 3. So we just the 9 is a fixture. It's just there. But let's find the pattern in the powers. It's arithmetic again, because it's adding the same number every time. So it's A1 plus n minus 1D. So the first term, the first power is 1. The D, the difference from power to power is 3. So distribute that. What is that? 1 minus 3. So it's 3n minus 2. So there's the formula. Now that's the power, though. So this is not, wrong line here. This is 9 to the 3n minus 2 power, right? The 9's a fixture. Now finally, how do we find the 100th term? It would be 9 to the 3n minus 2. Put in 100, 9 to the 3 times 100 minus 2. It's a 300 minus 2, 298. 9 to the 298. And then part E is about the same thing. See how it's the 130, it's 134 plus a number, some kind of number, times 3 to the 28th. That's always there. The 134, the 3 to the 20th. 134, 3 to the 134, 3. So the only thing that changes is the number. 6, 7, 8, right? So that's arithmetic. It's just going up by 1 every time. So A sub n is A1 plus n minus 1D. The first term, the first number that goes in that spot is a 6. The D, the difference from number to number is 1. It's only going up by 1 every time. 6, 7, 8, right? Distribute here. A sub n is 6 plus n minus 1. 6 minus 1, that's n plus 5. So then this is 134 plus n plus 5. That whole thing in parentheses, because that whole thing needs to multiply 3 to the 28. Right? That whole number multiplies 3 to the 28, so you need parentheses. If I didn't put parentheses, if I just wrote like that, that would mean only the 5 is multiplying the 3 to the 28th. We want the whole number multiplying the 3 to the 28th. And last step, how do we find the 100th term? We just take that 134 plus n plus 5 times 3 to the 28, and we put the 100 in right there for n. And so you get 134 plus 100 plus 5 times 3 to 28, which is 134 plus 105 times 3 to the 28. There it is, the 100th term. That goes right here, 134 plus 105 times 3 3 to the 28th. Okay, last thing here, number 18 now. Number 18, 2 hot air balloons are off the ground. So basically, let's make ground right here. This is all about drawing a good picture. Here's ground. On the first balloon, the distance from bottom of the basket to top of the balloon is 15 feet. For the second balloon, this distance is 20. The top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket. The top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket. So balloon 2 looks like it's higher up. So it's like we have balloon 2. This is balloon number 2. It says the top of balloon 1's balloon. So the top of balloon 1's balloon, like that. So this is balloon number 1. So the top of balloon 1's balloon right there is 6 feet above the bottom. This is 6, right? It's saying, right, the top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket, like that. And the top to bottom distance for balloon 2, it said, was 20 right here, 20. And it's 15 for balloon 1. Top to bottom is 15. Probably not making that diagram here. That diagram's probably getting a little confusing the way I made it. Let me make this go down just a little bit further so that'll be clear what it is I'm saying. All right. That good to there? And what else to say? If the distance from the ground up to the bottom of balloon 1 is 50 feet, so this, is that right? From the ground up to the bottom of balloon 1 is 50. How far is it from the ground? So here comes their question. From the ground up to the top balloon 2's balloon, from here to there, right? They want to know from ground to the top of balloon 2. What is that? Okay. Well, can we get the gap? There's probably a lot of ways to do this. Can we go from here, which is this bottom, to here, which is that? Can we get that measurement? Isn't it 15 take away 6? 9? Okay, so what? Well, then this is 50. Right here. 50, 9, and 20, huh? 79 feet. So a good diagram nails the problem. 79 feet. Okay, so number 19 is sets. They want me to find A intersect B bar. Okay, so set A is right here. It's the odd numbers. 1, 3, 5, 7, 9. Overlap. Now B bar, this means not B, or outside of B. So what is outside of B? B is 1, 2, 3, 4, 5. The universe on this problem, like everything that's possible, is 1 through 10. So B is, what's outside of B would be 6, 7, 8, 9, and 10, right? Because B is 1 through 5. And then now, what do we have in the middle here? We have overlap. So that means we want what's in common. The overlap between those. You know, what's in here and in here. Remember I told you that's like a big A for and. You put a line there, make it an and, you know. It means and. It means what's in here and in there, what's in common, what's in the overlap. So what's in both? Is 1 in both? No. Is 3 in both? No. Is 5 in both? No. Is 7 in both? Yeah. And 9, right? 7 and 9 is in both. So 7 and 9. All right, let's try part B. That was A. Part B, it's A bar overlap C. So A bar, that's what's not in A. So A is the odd numbers. So what's not A is the even. 2, 4, 6, 8, 10. Overlap. With C, what's C? It's right there. 3, 4, 6, 8, 9. Okay, now again, overlap. It's like a big A for and. It's what's here and there. What's in common. What's in the overlap. So what is it? Is 2 in both? No. Is 4 in both? Yeah, here it is. Here's 4. 4. Is 6 in both? Yeah. Is 8 in both? Yeah. Is 10 in both? No. And 9 and 3 are just in that. So 4, 6, and 8. 4, 6, and 8 are in the overlap. Let's go part C up here. B, unite. Now we're going into union. C and D are union problems rather than overlap. All right, so we'll start with set B. B is right here, 1, 2, 3, 4, 5. And not C, what's outside of C? Well, C is these guys, so what's outside? 1, 2, 3, and 4 are here. 5, 6 is here. 7, 8, and 9 are here. 10, that's not C. That's what's outside of C. And we want the union. Now, what does a union mean? It means unite. It means anything in here or in there. You unite, like everybody just come together. So that just put them all together. 1, 2, 3, 4, 5, just all these guys. And then all these guys, 2, also. You know, it's anybody here or there, but we don't repeat anything. So we don't repeat 1 and 2. We already got them. 5, or 5, we don't repeat that. Just 7 and 10. So that's the union. That would be the answer here. 1, 2, 3, 4, 5, 7, and 10. That's the uniting together of B with C bar. Let's try D. Right down here. So that was part C. So part D now. So A bar united with B. So A bar, what's not in A is the evens, 2, 4, 6, 8, 10. And B is 1, 2, 3, 4, 5. These 1, 2, 5. And so the union between those, it means, again, it's or. It's just unite them all together. So it's 2, 4. Whoop, what am I doing? I'm writing 2 twice. You don't repeat anything. So I'll just write the whole first set down. 2, 4, 6, 8, 10. And then I'll go to the next one. 1. Throw 1 in there. 2, already got it. 3, here I'll sneak a 3 in there. 4, already got it. 5, I'll sneak a 5 in there. There we go. That's the uniting together. That's everybody. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 8, and 10. That's the uniting together of A bar and B. All right, last 2 can be a little more tricky. Part E. It's asking for B union C bar over the whole thing. Now, when you have the bar over the whole thing, bar over all is opposite. You do the opposite at the end. So I'm going to do the opposite at the end of this problem. So here we go. So let's start with B. What's B? 1, 2, 3, 4, 5. And C. What's C? 3, 4, 6, 8, 9. And I'm supposed to take the union between them. So let's do that. That's just, remember, union means unites, or it's everybody here or there. You just write down the whole first set and then add to it. So 3 we've already got, 4 we've already got, 6, add 6 to it, 8 and 9. So that's the union. That's B union. So we haven't done the not yet. Haven't done the opposite yet. That's just B union C. And now, take the opposite of that. What's not in there? 1, 2, 3, 4, 5, 6, 7's not in there. 8, 9, and 10. 7 and 10. Just be 7 and 10. Let's try part F. All right, part F, bring it up here. It's A, overlap B, bar over the whole thing again. Opposite at the end. Opposite at the end because it's the opposite of everything. Right, so let's start with A. Do B over here. A is odd numbers, 1, 3, 5, 7, 9. B is 1 through 5, 1, 2, 3, 4, 5. I want the overlap. Now, what's the overlap? Is like an and. You got to be in here and in there. You're in the overlap. See, you turned over. It's like a big A for and. So, is 1 in both? Yeah, it's right there. Is 3 in both? Yep, there it is. Is 5 in both? Yep, there it is. Is 7 in both? Nope. Is 9 in both? Nope. Is 2 in both? Nope. Is 4 in both? Nope. So it's 1, 3, 5. So now we're not done yet. That's the overlap. That's A overlap B. And now last step, we have to do A overlap B opposite bar. So the opposite of 1, 3, 5, the opposite would be what's missing? 2, 4, and then 6, 7, 8, 9, 10. That's all the numbers missing. That's the opposite. 2, 4, 6, 7, 8, 9, 10. Okay, so here on number 20, they want me to do a Venn diagram for A union B complement. So this is A, this is B. Okay, so I'm going to do it in 2 stages. First off, A, circle A, so I'm going to just do everything that's in A. There's all of A. I'll do in a different color, B complement. Now that's the same, that means B bar. That's just another way of saying what's outside of B, meaning opposite of B. Either way you want to say it. Opposite of B, outside of B, same thing. Everything not in B, outside of B. So I'm going to shade like the sunshine here. Everything outside of B. Okay. Now, what do we want as our... Now, I'll come down here. I'm going to do our final answer. Draw A, draw B here again. Here's A. Here's B. So how do we do now a final answer to this problem? What do they want from me on this problem? Well, what's in the middle is the union. Huh. It's the union in the middle, and that means or. Anywhere there's green shading or there's blue shading. That means unite together all shadings of all kinds. So where's that? Well, I see shading everywhere except right here. Huh. So that's the only thing not shaded. So the answer is going to be shade all of this, shade this, and shade this. Shade everything except this area right here, the B only area. Now, if they had said, now careful on the final, it's going to be random. They could have had the overlap symbol instead. That would mean only where the 2 shadings, the green and the blue, overlap. What would that be? Let me do that up here. Let me just do 2 answers. Here would be the overlap answer, and this one down here is the this one is the answer to our original question. Okay, but what would be the answer? Let me go back here. What would be the answer? Here's A and B. If they had said overlap, right? Overlap. It'd be only where the green and the blue shadings overlap. Where do you see them overlapping? I only see them overlapping right here. Right in this zone here. It's only where both shadings exist. That would be the answer to overlap. This is the answer to the union of the 2. Does that make sense how to do that? So you just do each one separately first. Do the green shading for A. Do the not B, outside of B shading for blue. And then come to a final answer for union or overlap, depending on what they ask you. Okay, so number 21, fraternity, 33 members, 18 take math, 5 take math and physics, 8 take neither math nor physics. How many take physics but not math? So we need a Venn diagram. So we're going to have math and physics. Okay. 18 take math. Now, can I just put the 18 there? No, because it means however many are here and here together must make 18. I don't know, either one yet. So what can I do? It says that 5 take both math and physics, so 5 go in the middle. Now I can go back to, okay, 18 total in the math circle. Must be 13 there. See how that 13 and 5 makes 18 total in the math. 5 doing both. 8 take neither math nor physics. They're out here. Neither math nor physics. And it tells me there's 33 members total. So if I add up 13, 5, and 8, get that total, subtract from 33, I can get the blank. What's that? 11, 16, so 26. So 26, take that away from 33 total. What do you got for 7? So therefore this must be 7 to make 33 total. How many take physics but not math? Well, that's these guys, these 7, because they're in the physics circle. See? They're in the physics circle right here, the physics circle, but they're not in the math circle. See how the math circle over here? They're not in the math circle, but they're in the physics circle. 7. Okay, number 22. In a state of 532,000 to 3 siblings. The eldest receives 6 times as much as the youngest. The middle receives 12,000 more than the youngest. How much did each receive? So we're going to have oldest, middle, youngest. It says the oldest receives 6 times as much as the youngest. Let's call it 6y. Let the youngest be y. And the middle is 12,000 more than the youngest. So that's 12,000 plus the youngest. And now I need to write a formula. 532,000 is for all 3. So that would be 6y plus 12,000 plus y plus y alone equals 532,000. Does that make sense? It's easy to accidentally leave out this other y, because you might look, oh, I got the oldest, the middle, the youngest. There they are, got them all. But no, that's not right, is it? Because the 12,000 plus y, those two things are the middle. So you need a separate y to be the youngest, huh? And over here, this is the oldest. Right? So don't forget about that separate y. It's easy to do that. All right, let's solve this thing. What do we have now? 6y and 1y. That's 7y. Oh, and another one. That's 8y. I'm forgetting about the other y too. So we got 6, 7, 8. 8y plus 12,000 is 532,000. Subtract the 12,000 from both sides. 8y equals, what is that? 520,000. And last step to get y alone, divide by 8. Y equals, let me get my calculator. I'm getting 65,000. So that's the youngest. So we just go back now and plug those in, don't we? So the youngest, it's 65,000. The middle is 12 plus 65, and that would be, what's that? 77,000. And the oldest, it's 6 times 65,000, which comes out 390,000. The youngest gets the straight 65,000. There we go.